We're going to look at average and instantaneous velocity now. We have a great table here that gives us amount of seconds and specific distances that happened then. We had a ball thrown straight up in the air and it came back down. So to compute the average velocity over time, we're going to look just at that, the change in the distance over the change in time. So going from the interval of 0 to 1, I'm going to pick off the 90 minus the 6, and then going in the same order of the time there. So 1 minus 0, and that's going to reduce to 84 over 1, or 84. If I go 2 to 3, and I'm going to do 162 minus 142, and that's 3 minus 2, or 20. Here's a couple for you to try. Pause the video and check those in just a second. Here's the answers to all those average velocities over those specific intervals. The formula for average velocity, as you've seen, is just the change in the y's over the change in x, the rate of change, or we like to call it the slope. When I'm looking at a velocity graph and I want to say, what does average velocity look like? Well, average velocity is the secant lines. You can pick any 2 points and you can draw a secant line, meaning touching the curve twice, and you're going to find the slope of that secant line. Obviously, the more closer the points are, the better it's going to be. Now we're going to get into instantaneous velocity, and you're going to notice that it's now at t equals 2, just 1 specific second. So in doing that, I'm now looking at a smaller interval. Now, if I have a table, I have to do what I have available here. So the options I have, I could do the interval from 1 to 2. So that would be 142 minus 90 over 2 minus 1. So that's going to reduce to 52. I could do the interval, so that's the interval of 1 to 2. I could do the interval of 2 to 3, and that would give me 162 minus 142, 3 minus 2. That one is 20. And I could also, so we've got 2 to 3, I could do 1 to 3. All of these are options. So 162 minus the 90 over 3 minus 1. And that's going to give me 72 over 2, which is 36. Now another interesting thing you can do is take the average of these two, 52 plus the 20, divide that by 2, so you're going to get the 72 over 2. And again, there's 36. So these are just different options of how to approximate the instantaneous velocity. I'm going to give you 2 to try here, so pause the video, check these out. Here are some answers for the approximations that you could have there. When I'm looking graphically at this, now instantaneous is considered the tangent line at those specific spots and finding the slope of that. So we're going to say instantaneous velocity equals the slope of the tangent line at that point.